Hello, I'm Nilesh, and today I'll be explaining compressed air energy storage system. And this technology stores energy by compressing air into underground caverns or tanks. Later, this air is released, heated, and expanded to generate electricity. It works. This system works like a giant rechargeable battery, but instead of chemicals, it uses air. This makes compressed air energy storage especially useful as we move toward renewable energy, which is not always available when we need it. So coming to the next slide, the compressed energy storage system was first built in Alabama in 1991. It showed that energy could be stored at a large scale by compressing air into salt caverns and then releasing it to drive turbines. One challenge with this plant was that it needed natural gas to heat the air before expansion, lowering efficiency. Still, it proved that compressed energy storage could reliably provide backup power and operate continuously for decades. Talking about how compressed air energy storage system works, they basically work in three main steps. First one, there is extra electricity available, for example, from wind turbines or solar panels. That electricity powers compressors, which squeeze air into underground caverns or high pressure tanks. Second, the compressed air is stored there often for hours or even days until the energy is needed. Finally, when demand rises, the compressed air is released. It is heated either by burning a small amount of fuel in older systems or by using stored heat in modern designs, and then expanded through turbines to generate electricity. In short, this system captures excess renewable power, stores it as a pressurized air, and then converts it back into electricity when the grid requires it. Now, at this slide, let's look at the timeline of compressed air energy storage development. The very first plant was built in Germany in 1978. This was a 290 megawatt facility that proved compressed air energy storage could work at utility scale. In 1991, the plant in Alabama, US, became the second commercial system using underground salt caverns for storage. Both of these plants are still operational today, showing durability of this technology. In recent years, the storage system has entered a new phase of global growth, with larger and more advanced projects under construction in China, Europe, and North America. This timeline shows how this storage system has evolved from early demonstrations to a proven modern energy solution. Since the early plants, modern advancements have been made so that this system can be made more efficient. As we know that this compressed air energy storage stores the heat generated during compression and reuse it later, reducing waste. And these improvements means that this storage system today require less fuel, produces fewer emissions, and you can compete better with better battery storage systems. Now, coming to next slide. Today's CA compressed energy storage, air energy storage system plants have a combined storage capacity of more than 500,000 megawatt hours. That's enough to power hundreds of thousands of homes. And modern plants can also reach efficiency of about 70% compared to around 40 to 50% of older designs. These numbers show that this storage system is not just proven but also improving steadily. On this slide, this chart shows how compressed air energy capacity has increased over time. Each point reflects new projects being added or expanded. You can notice the steady upward trend, which signals growing investment and confidence in technology. More capacity means more renewable energy can be stored and used when the demand is higher, which will benefit the environment as well. Compressed air energy storage offers several key benefits. First, it provides long duration storage, meaning it can deliver electricity for many hours or even days, something batteries often cannot. Second, it improves grid stability by balancing supply and demand, especially when solar and wind power fluctuate. Third, this system is environmentally friendly since it stores excess renewable energy and reduces the need for fossil fuel backup. It's also scalable. Large underground caverns can store huge amounts of energy to power entire cities. Finally, these systems are very durable. We can see the examples of the plant in Huntroff in Germany and an Alabama plant, which have been operating reliably for decades. Together, these benefits make this system a powerful partner in building a cleaner and more reliable energy future. Compressed air energy storage system has a positive impact on the environment because it helps us use more renewable energy by storing excess wind or solar power when it's not needed and releasing it later. This system reduces our reliance on fossil fuel backup plants like coal or gas. This means fewer greenhouse emissions and cleaner air. This system also has a relatively small physical footprint since storage often uses natural underground caverns such as salt caverns, domes rather than requiring new land development. Modern design like adiabatic compressed air energy storage even recycle heat from compression, making the process more efficient and reducing fuel use. Altogether, this system supports a cleaner, more sustainable energy grid, helping countries reach their climate and emission reduction goals. While talking about the applications of compressed energy storage systems, as the systems has many applications in modern energy systems, it stabilizes the grid, supports large renewable energy farms, and provides backup during peak demand. In China, these plants help store wind power, while in Europe, it's used for cross-border energy balancing. Its ability to provide long duration storage makes it a valuable partner to batteries and other storage methods also. And with this, I would like to conclude my presentation. And to summarize this energy storage, I would say that the compressed air energy storage system are a very reliable, efficient, and environmentally friendly way to store energy. It supports renewable energy integration and stabilizes power grids and reduces emissions. Thank you.